Okay, sample number one. A ball is hit at 53.1 degrees above the horizon, has an initial velocity of 10 meters per second as shown, and it's on a whopping 400 meter high cliff. Giant cliff. You guys have the picture, don't you? Yeah. Okay, now you might say 53.1 degrees, that is really weird. Don't write this stuff down on the right. You're going to write down as we go. Don't write now. Okay? We're going to do each one step. The 53.1, there is a reason for that. Okay? All right, so let's find the vertical component. Now, just as a refresher, I need 53.1, and it's 10 meters per second, right? Okay. So VV is the first thing you're going to find, right? So this is 10. This is 53.1. And so VV is opposite, so it's going to equal V sine theta. Basically, the first step is to break the velocity into up and down components. And if you want to write that down on your cheat sheet as you go, step one, break it down into components. Hey, that's a good idea.
When is that test?
Oh, I'm thinking about, today's Friday, I'm thinking roughly next Friday. Ish. My marks are due on the 13th, which is
Monday, and we have breakdown.
oh, right. So if we want this test to appear on that, that's going to be a lot of strain on me. Because I got to mark the test and do the report cards. We'll see. We'll see. Well, a week after the 13th, Josh.
Not even a good chance.
Okay, so you've got 10 times sine of 53.1. Now, the reason that I picked 53.1, when you take the sine of that, you get, I'm in radians, that's why.
VV is Y, right?
Yeah. What is love?
V horizontal. What is V vertical?
V vertical. Yeah, so that's going to be 10 sine 53.1, right? And the sine of 53.1, I know why I picked this. Yeah, it's 0.8. It's a nice 0.8, 0.8 is the sine of 53.1 multiplied by 10, of course, is going to give you 8. That's why I picked 53.1, because it's a nice even 8. And VH is going to be 10 cos 53. And maybe you're thinking that the cos of 53.1 is a nice round number, and it is. It's 0.6 times 10, 6 meters per second. Okay, which is the reason for those.
And you're times 8 by 10 because of the
Because
velocity?
it's 10 times the sine, right? 10 times sine 53.1. You're just breaking it into components, right? That's all you're doing. Okay, so our components are 8 and 6. Now, time of rise. So we have to find how long it takes to get to that point there. Now, what's special about that point? What's happening? What's unique at that point?
0.
What's at 0?
How fast is it up?
Which component of the velocity?
Initial velocity.
The gravity.
The vertical component is 0. It's not going up anymore. Right? It's not going up, it's not coming down. The vertical component there, the VVF, if you will, is 0. Right? And we want to know the time of rise. Do we know the initial? Yeah, it's 8. Right? It's 8. Do we know the acceleration? No. Negative 9.8. Right? So it's a pretty straightforward application of VF equals VI plus AT. Again, an old kinematics friend. The VF in this case is our final vertical component, or 0. The VI was 8 plus minus 9.8 T. Right? So T is just 8 divided by 9.8.
And we have to put the negative in there.
Well, when the A goes to the other side, it's going to become negative. Time has to be positive. And so the time of rise is 0.82 seconds. height of rise. How high does it go? That's not really an H, it's more of a D, I guess, right?
Oh, we'd have to use this one formula here.
We got a couple. We could go VF squared equals VI squared plus 2AD. We could go D equals VIT plus a half AT squared. You like that one?
I like the first.
Okay. Well, you do it the way you want, right?
I'll just follow.
Okay. One more outburst like that and we'll clear this courtroom.
So,
What's the VIT?
people who.
Oh, it's nice when it's 0, isn't it?
Yeah, it is, but it's not.
Let's
Nah, is it?
say one more outburst and we'll keep
Yeah.
this court.
It's going to be 8 times 0.82 plus 1/2 minus 9.8 times 0.82 squared. Ugh. It is kind of gross.
Yeah.
8 times 0.82 plus 0.5. Oh, now is that negative? Now you guys always worry about the negative. Is it important here?
No.
Is it squared?
I don't think it matters.
He's throwing a curveball.
Bingo. If we just had the VIT, I think it was Turner I was talking about this, right? Like this is the constant velocity. This is the distance it would travel in 0.82 seconds. It would travel at a constant 8. But it's also slowing down, isn't it? So it's going to travel less. So the negative is very important here.
Oh,
The negative is very important here. That's what I'm getting at. Okay, so let's work this out here. So I got 8 times 0.82. And I'm just going to go subtract minus 0.5 times 9.8 times 0.82 squared. You should be able to do it all in one step. And I get an answer of 3.3, we'll say. 3.3 meters. And if you want to just try that on their own to make sure you can get that, that's fine. I'll take a second and do my attendance. No?
Yeah, I had to do, I actually got stuck.
It's okay. Do you want me to give you a hand with that? Come
I
on.
actually cleared mine.
Go 8 times 0.82. And then I'm looking ahead and seeing one negative. So I'm going to go subtract 0.5 times 9.8 times 0.82 squared. And then you got to hit equals. Got to hit equals. 3.3.
3.26.
You're wrong, Josh.
you went subtract what?
So you're putting subtract because
Just about.
Well, because this is a negative, right? I mean, you could go plus 0.5 times negative 9.8, but it's just easier to make it a subtraction.
So, wait, did you say that, how you did it again? Just
8 times 0.82 minus 0.5 times 9.8 times 0.82 squared equals. I'll come by, Josh. I'll have to come by and show you individually.
Okay, I got it. Thank you.
You didn't, because you would have got 3.3.
I got
Well, is that not true?
yeah, I got like 2.4.
I'll come by and I'll help. So 3.3. Okay, now, total time of flight. Is the time up equal to the time down?
Yes.
Only if, in fact, I'm going to even
can add it.
rephrase that a bit. Only if the launch height is the same as the landing impact height, right? Okay, so the time up is not equal to the time down.
But you can still add it to.
So there are two ways to deal with this, okay? There's the long way, which I will show you, and then there's the beautiful, elegant, and really smart way. You want to do the beautiful, elegant, really smart way first? Okay, sounds good. Well, it's up to you. I like this one because it makes me feel smart.
How do we know that?
Because we're
Yep.
throwing.
I like this.
Okay, so the displacement, how high is this clip again? 400?
Yep.
Okay, so the displacement is minus 400 because it starts off here and it ends up here. The vertical displacement is minus 400. So we're going to go D equals VIT plus 1/2 AT squared. And we're going to say our displacement is minus 400. And our initial component, it's the vertical one, right? So it would be 8T,
80.
no, 8T plus 1/2 minus 9.8 T squared. And yes, you can soon see it's going to be a quadratic.
So it's side of the,
Do what?
so it says on the opposite side.
We'll do that. We're going to do that. We're going to do that. Okay, so set that up as quadratic. Now, this here is going to be minus 4.9, right? No one likes a minus in front of their T squared. Nobody likes that. So take it to the left. So it's going to be 4.9 T squared. The 8T goes also to the left. So
Wait, how'd you get 4.9?
1/2 times 9.8, right?
Okay.
So take the minus 8T to that side, and I'm going to leave the minus 400, and the whole thing is equal to 0. Right?
So you just took everything over. Okay.
How do you solve that?
You take a T out.
You can't.
Factor out 4. You keep the grades on factor.
Well, you know what the factors of 400 are combined with factors of 4.9 that add and subtract to minus 8?
I know.
A Punnett square. Oh.
Gotta be easier to get this front square.
Mr. Ray hated me.
Can you not?
Should we race? Turn?
Yeah.
That's the only way I can factor.
Okay. You are not going to factor this.
You can't use the quadratic.
Of course you can. You can always use critical. You're going to get decimal values, so unless you're willing to literally check like every decimal 0.1, you'll be there forever doing that. You'll like go through miles of paper. So x, right? Like it's not like all integers, right? Yeah. So x is equal to minus b plus or minus square root b squared minus 4ac all over 2a.
I can never do this. I hate it.
I hate it.
I hate it so much.
So minus b is going to be minus minus 8 or 8 plus or minus square root. B squared is going to be minus 8 squared, or just,
Bloody paste.
yeah. Let me just explain. 64, right?
Yeah.
You know what? Just for the sake of minus 8 squared minus 4a is 4.9 and c is minus 400. All over 2a, 2 times 4.9. So 8 plus or minus. Okay, so minus 8 squared is 64. And then you've got a negative 4 to negative 400, so that's going to be a plus. So 64 plus 4 times 4.9 times 400, 7904. Plus or minus the square root of 7904, all over 9.8, right?
Yeah.
That's what I got. Okay, so you're going to have to do the add and subtract. Well, let's just hold on here. Let's go 8 plus or minus, square root that first. 88.9. Yes, that number rings familiar with me.
Why is that?
I just have done this question so many times. Now that I see the number, I'm going, oh yeah, I'm on the right track. So it's going to be 8 plus 88.9. Divide by 9.8, and you get, that seems weird.
You get what?
Did you get 9.89?
No.
Mervyn got it.
9.89 seconds.
Mervyn got it, then we did it.
Then we did it. Should I do the negative?
Yeah.
No.
Well, 8 minus 88 is going to be negative 80. Divided by that is going to be a negative value. Okay? So this value right here is 9.89. Now,
Minus
88, is that not like 80?
Minus 80. 8 minus 88.9, right?
Okay.
Actually, if you continue this, it's going to be this time right here, which is a negative kind of thing, right? Doesn't exist in physics.
Man, that takes so much more time.
Perhaps. Now, if you know something like,
Playing cards.
Yeah, I didn't do that first.
Oh,
if you've got some sort of feature like this, you guys play with this in math class?
Oh, great, Desmond. I still have the app.
4.9x squared. What's the b value?
what?
What's the b value?
8, minus 8t.
Minus 8x
Minus 400.
minus 400.
Oh,
Okay.
what the heck is going on? Miss-
Well, we just graphed it.
Just gotta zoom out, see the
See?
parabola.
There's the parabola.
It's upside down.
Very skinny parabola. Well, it's a pot. We changed it into a positive, right? So what's this value right here?
Oh, Jesus.
9.888.
Holy cow.
If only we were allowed some type of graphing calculator type device on these tests. Or if you could just punch it into your phone and use it.
I have the app.
I would suggest you learn how to do that.
What?
Yeah. You're solving a problem.
That's a we know.
A problem.
You're solving a problem using a tool. Okay, so I consider this to be the elegant, I'm smart way. Okay, the other way is to do this, right? We've already figured out, and Christine's figured this out, we've already figured out the time, or the distance up. How much was it? Like 3 meters or something? 3.3? Okay, so could we just figure out the time it takes to fall 403.3?
Yeah.
And take that time and add it on to? Would that work too? I think it would,
It
right?
seems so much easier.
Yeah, well, I mean,
Oh, brain.
okay, so that would be, let me do it on the next page. So, well, it says range, but let's insert a blank page. Okay, so the D is minus 403.3, is that correct?
Mm-hmm.
Okay, so now you're just going to find that time. D equals VIT plus 1/2 AT squared. So minus 403.3. Now what's the initial velocity at the top of that 403? 0. Oh, this is nice, isn't it? 0 plus 1/2 of minus 9.8, right? Okay, so minus 403.3, that's 0. This is going to be minus 4.9 t squared. So t is the square root of 403.3 all over 4.9. So 403 divided by 4.9, and take the square root. It's not a second function. 9.07. Nope, 9.07. 9.07. Well, that's not the. We got 9.88.
We have to add the point.
Right. You gotta add on the time up, which was 0.82.
Wow.
9, 8.
Why would you scare me?
That's so much easier.
Well, it is, but remember,
That's the up number?
9.07.
Other way? Yeah, I thought it was
No.
yeah.
The
Remember though, remember, we did one step here. I also had to do these 2 steps, didn't I?
Yeah.
yeah, but that's like easier.
Yeah, but if you didn't know that, if you didn't know.
If you didn't know these, you'd have to do them, right? I purposely forced you to do those so that this would be a one-stepper. But keep in mind, you got 1 step, 2, 3. Whereas here, could I did it all in 1 step?
Got 2 steps on the side.
Well, fair enough, but
I mean,
Steps that you have to do to get this.
the ones before, the time of rise and the height of
we
rise.
practiced the other way a bunch more.
Whatever. I like showing kids this because I just think it's cool how you can set the displacement to that minus and you can make it all work out.
That is
I haven't
cool.
copied down all of it yet.
But it's confusing and hard for me.
You do which way you want, guys. Okay, so I hope you guys all enjoy that $20 bill that I handed everyone.
We waited like 5 minutes.
Okay.
And be sure not to lose those exam answers.
Oh.
Oh, look at all these.
Oh, hi, Megan. And now we need to find the range.
Great. I don't even have any space.
I got
No space?
No
Yeah.
space.
Look how much space I have.
I got another.
Because we still got 2 more parts to this.
Oh, I am doing.
Well, I'll just.
Now, the range is really only just 1 step. The range again is the horizontal distance. What's the horizontal velocity? 6. Way back to here, right?
The horizontal acceleration.
The horizontal rate of acceleration is 0. The horizontal velocity is 6. So I'm going to show you two. Just watch for a second, and then decide which way you want to do it. Okay, just watch. So you can go v bar equals d over t. It's 6. We're finding for d. My time was 9.89. They just got moved. That's all. 9.89, I think, right? So 6 times 9.89, 59.34. Now, if you want to think of it this way, this is what you and I were talking about, Karen, the other day. If you go d equals vit plus 1/2 at squared. Because really all I did here was multiply the velocity by the time, right? So if I go over here and go d equals, the vi is 6, the time is 9.89 plus 1/2. Now what is my horizontal acceleration? 0. So 0 times the time squared. Well, anything times 0 is 0, so all of that just disappears,
Oh
right?
crap.
So really, I want to show you, really, this formula is just this one with the added part of the acceleration. That's all it is. Okay, so you're going to get exactly the same thing. Well, the problem though is that kids that why do we use this one? Because you use this one when the velocity remains constant. In other words, when the acceleration is 0. Right? I'm just making the connections for you.
Right. So we can always use that one for every velocity coordinate.
Thank you, Jared. So we're finding the components. The horizontal velocity is 6, and we have to find the vertical component at impact. So 8 is the initial, plus minus 9.8. That time again, 9.89. So my vertical component, how fast is it going up and down? 8 minus 9.8 times 8 times 9.8 times negative. I get, is that right? Minus 775?
No, I get minus 17.
Oh, it's way more than that.
I got 88.
8 minus, I'm in stat mode here somehow.
So it's 8 minus 9.8 times 9.
Wait,
I got 88.9.
There we go. 9.8 times, and that's negative, plus 8. Yeah, 88.9. Oh, yeah,
So with the mass of, if the object had a mass, would it change anything?
no,
Oh,
no. Okay, now that's just the vertical component impact, right? So what do I have to do?
Wait, so it's 8 minus 9.
What's that? Yeah, it's negative, but I also know that over here I'm going to square it, so.
square.
Okay, so now we've got to do some Pythagoras. Yes, I do apologize. I should have warned you.
Or why is that all squared? Why? What's going on?
Because we're doing we're combining our components now, right?
Yes, yes.
I get 89.3.
square rooted?
Yep.
Okay, wait, so the 8 is the.
The 8 is the, oh, it shouldn't be 8.
It should be 0.
It should be 6, although it's not going to make a whole lot of difference, is it? It's 6. It's this number here. It should be 6.
So that's VH and D.
VH and VD, yep. It's not going to make a whole lot of difference because that's so much smaller than 88.9.
I'm confused about the 8.
So, oh,
89.1. Meters per second. Okay, Christine, what's the problem?
Is the VI that's your vertical initial velocity?
This is the initial vertical, the 8, right? But it's being accelerated.
I get that, but I thought it was just
Oh.
VI for vertical, because it's like 0.
No. You're thinking of the horizontal acceleration. The VI, right back to the start. Right? The VV was 8, the VH is 6. That is my initial vertical.
Is that like so after it's already started falling down, like when it's at.
No, that's the initial 8. But it started off at 8, and it was accelerated at minus 9.8 for a total of 9.89 seconds.
So that's like the 8 is going up?
Yeah, but that's okay. The negative 9.8 will slow it down, right?
Okay, I get it now.
And over that whole time, we'll turn it into a negative.
Okay, I get it.
Okay, now last step, you got to find that angle. So that's going to be inverse tan, opposite over adjacent. So 88.9 all over 6.
why do we have to find the angle?
You've always got to find the angle.
Does that say 6 equals?
No, theta equals.
You don't hurt.
Oh, so we can use that one formula to find the, what?
86.1. We'll say 86 degrees BTH. It's literally going almost straight down, right? That's a lot of steps.
That is.
Is there some easy way?
Would this be like the biggest smart question?
This is the biggest mark question on the exam.
Like what?
Oh, Jesus.
Holy cow.
There's no other simple way.
Nope, that's it.
So when you.
There's no smooth way to smooth this over.
6%.
I think it's 11
Wait,
marks.
what is that?
Okay, so when you
Does
would
it say
ask this
86
question, like in the first
degrees
page,
south?
it had like all those.
Yeah.
Below the horizontal.
I probably won't put all those steps down. I might just say, what's the velocity impact and what's the rate?
Okay. So you need to know like all the.
You need to know the
But you have to
steps.
be able to do it in our sector. I have a question.
All of them.
Did I see steel?
Okay? That took quite a while to do, right? But I mean, I was explaining as we went. Now, for some reason, I have this one here, and this is not really a type 7. You know what, how about we take a moment. Here's an unknown question. Let's identify what type of problem this is. Maybe we should spend more time doing those kind of things too, right? So here's a stunt man attempting to jump 40 buses
It's a lot of us.
using a 40-degree ramp. His speed is 130. Each bus is 3 meters wide. Will he make it?
No.
I guess it could be a stunt woman. It doesn't depend on gender whether they make it or not.
What kind of question? Is this another?
Well, what is this? We got buses. We got these buses, right?
So,
And each bus is 3 meters wide. There's 40 of them, so this distance here is going to be. You don't draw 40 buses. Just the motorbike has to clear 120 meters, right? So level ground, right?
Yeah.
We got one ramp at 40 degrees. So the bike's going to go,
That's a lot of buses.
right?
I don't.
The bike's going to go like
oh, the bike's gonna make it.
like that, right?
There's like.
Okay,
That's the motorbike, yeah.
buses.
Doesn't look like a motorbike to you?
Not really.
It kind of looks like a.
And then he's gonna like bounce.
Yeah.
It looks like a Euro
Start-
symbol.
Yeah.
Do a barrel roll.
So what type of problem is this?
Number 2.
2.
It's horizontal graph. Does it matter that the buses do we know how tall the buses are?
No, but we know that's 3 meters
Oh,
wide.
he's not touching the bus.
He's not touching the buses, right? So literally, it's like this is the ground here, right?
Okay. If you land right on. What?
3
Well,
580.
okay. What are we solving for?
distance.
This,
But we know the distance.
No, but you want to know the distance he's.
Right. This is how far he has to go.
You want to know how far he has.
Will his distance be more or less than 120?
Yeah.
Like,
What's that?
he goes exactly 120.
I don't know.
Yeah.
What's your-
Well, but do you really think the answer is going to be like 120 exactly, or do you think that we're going to get a D value of like 135?
well, then he'll make it.
Hold on, let's shot no box, see?
Yeah, let's figure it out. Come on.
Now, shall we try this the elegant way?
Now, can we do it like the easiest way possible so my brain is not already strained?
Pick out the cake. Or did he also show like Banku and Dunkin'?
Well, the easy way is the elegant way in my mind.
I like the other.
Thanks, Talia. How about I just do the elegant way myself, without any commentary, and you guys decide whether you like it or not.
Well,
This involves the quadratic. This involves the quadratic.
Doesn't.
No, because you're doing it the
Let's do it.
Let's do
wait, no, just
130 kilometers per hour divided by 3.6,
wait. 98.6.
36.1. Please don't forget that step. That step is in there literally to give you a chance at an easy mark.
Oh, I was gonna ask.
36.1.
Or just to ruin up the whole calculation.
Don't mess it up. 36.1. Okay, do we need to break it into components?
36.1 what?
Meters per second. Yes, we do.
Sure we do.
So, VH is going to be 36.1 times the cosine of 40.
We can't combine it.
27.7. I haven't combined anything.
Nothing on different.
Don't joke about physics, Riley.
Okay, cool. You're good at putting the slammer.
23.2. Okay. Oh yeah, we're doing it the elegant way, right?
I don't want to do it there.
What's the overall vertical displacement?
Zero.
Why do you say that?
It's the
Yeah, it lands exactly the same spot that it took off. The overall vertical displacement is 0.
What if you overshoot the ramp?
Well, we just have to know, how much time will it take to get there, right?
Mm-hmm.
That's what we're going to solve for. How much time will it take to go?
Then there's this big gust of wind.
Yeah. VIT equals 1/2 AT squared. So 0. The initial vertical is 23.2 T. Now, can we just do this, big boys and girls? Can we go 1/2 A? We know A is going to be minus 9.8. We know it's 1/2. Can we just write minus 4.9 T squared? I hope by now you've seen that pattern. Now,
Oh,
that's a quadratic.
But you can do the quadratic formula.
You can, but you don't have to.
Yeah, you take out the t
Yeah,
and then
you
go to
solve.
the
Yeah,
y.
exactly. You can do the quadratic. There's no c, right? So you can factor out. You can go 0 equals t times 23.2 minus 4.9 t. T is 0, or that's going to be minus 23.2 all over minus 4.9. This is the elegant way, by the way.
It could be minus
Why did you-
9 over 23.2. No, 'cause you have the 4.9 technically.
The 23.2 has to go the other side. And then you're dividing by the one you multiply by. You always divide by the one you multiply by, right? 4.7 seconds.
That's the
That was the
time.
alligator.
Danielle, here we go.
That's the time. in there.
23.2 minus 4.9 t is 0. Right? Minus 4.9 t is equal to minus 23.2. Divide both sides by minus 4.9, right?
What's going on?
You always divide by what you multiply.
Wait, what's that number right there before the minus? Like the big 20?
Wait, why'd you just?
Oh,
Because see, like, you put.
never mind.
Riley's on top of
Excellent job, Riley. Megan will be very pleased.
Thank you.
Okay, so it's a constant velocity, so we can use that v-bar thing. So the constant horizontal is 27.7. We want to know how far downrange we are after 4.7 seconds. Right?
Mm-hmm.
So we're going to take that 27.7, we're going to multiply by 4.7, and we get 131 meters.
That's perfect.
Made it with like 10 meters to spare. In fact, that ramp better be a little bit longer.
Yeah, did you watch a video where
We did watch where you want to land on the ramp. Why does that work? Like if you land on the ramp, why is that safer than just on the ground,
Because
flat?
it takes away some of the impact.
Yeah, sort of. It takes it away. Yeah, like you're continuing to go down as you're slowing down. It basically increases the amount of time.
they're like crazy.
Yeah, it's kind of like doing this with a baseball, right?
It's not such a big instant stuff. Like if you just catch an egg like this, but if you
Right.
roll-
Exactly.
Yeah,
We'll come back to that in a couple units.
it's a
In a couple of years.
Alright.
Darn.
Now, what would be the non-elegant way of doing this? You'd have to find the time to the top, multiply by 2. That would give you the 4.7, and then do the same step, right? So it's really not that hard.
Wait, how would you find the time to the top again?
The VF would be 0. Your VI would be 23.2. So it'd be VF equals VI plus AT. Solve for T, multiply by 2. Two-step.
How many marks in this question?
This would probably be worth, well, there'd be 1 mark there, 1 there, 1 there. Maybe not. I don't know, probably only 1 there.
I don't know.
I'd say 5. Okay, I am done talking.
Sam.
There is one more. How about you guys try this one without an answer? Try that one for Monday. Want to do that? This might take you a while. You probably won't get it done in 10 minutes.
Well,
This is the same as the 11 mark one, yeah.
I gotta drive to Brandon Sunday.
You drive to Brandon Sunday, Riley?
Yeah.
Okay.